on, let me go. The dull reverse 4-bar build. Last time we stopped with one of the pods being done. So the first thing that we're going to do today is double this pod. So the way that we do that is you can, well, there's two ways you could do it. One of the ways is how I showed you before, where if you grab from the top left and drag to the bottom right, you get this red box, and anything that's completely selected inside of it will copy. So if the motor's not in it, the motor won't copy, but everything else will. Or you can use the top right to the bottom left, and anything that is combined will get picked up. So even if barely any of the metal is in there, it'll get picked up. So we can just, once everything's highlighted, you could just Control C, click somewhere over here, Control V, and you have another one. Now what you would have to do with this is you'd have to rotate it and switch a couple parts, because as you can see, the motor has to be on the inside, and these are on opposite sides. So actually, what I'm going to do instead of that is I am going to take a, where is it? Mirror, and then you just want to click every part, because that's the only parts that are part of it so far. So that's all of your components. Then the mirror plane. Let's see which one of these planes. So if we look straight on it, this plane is the right orientation, so that'll work. And then we'll just have to move the parts either left or right in order to fix it. So we'll click that plane, because it's basically, if everything was reflected over that, it would be in the right orientation. See, it shows you a preview. So now, mirror relationships, you need to make sure that's clicked on. We don't want to ground new components because we're going to have to move them around. So then click next. And it'll basically make this part I'm not a big fan of, but it's just the way that it does it. It makes a different part with the same exact name, but underscore mirror. So this stuff, like, just make sure you save it in the same spot that the project is in, because you're going to get a lot of file names when you start adding these mirror files in. But you can just make sure they're inserting in the assembly. Oh wait, maybe I can turn off the suffix. If I turn off, or if I just, let's turn off the suffix, maybe that'll work. Maybe it won't make a new one. And then click OK. And it'll take a couple of seconds to render, and then all the new parts will pop in. Okay. I don't know why it says mirror components failed. Let's click accept. So you have all the mirrored parts. Sometimes the relationships get messed up, so it's just best to test it out. Just make sure that, does this rotate? No, it does not. Okay, so we need to make sure that the relationships are right. So it copied the relationship of this being grounded and this being grounded, but we don't want this one to be grounded because it's going to be moving in and out, so we can get the spacing right. So I'm going to right click that and unground it. but now you just need to do some diagnostics to figure out why it's not working. It's most likely a relationship thing, but so what I would do is right click the relationship, and you can click suppress, which doesn't delete the relationship, it just makes it as if it wasn't there. So you can suppress it and then drag it to see if it'll work. Now I don't know why it's not working. Okay, what's wrong with this relationship? Okay, sometimes when this big exclamation mark is next to it, that means the relationship is broken. So we know that when we highlight over this, this is the relationship that we use to connect the bearing or the axle guide to the metal C channel. So I'm just going to delete it, and I'm going to just basically redo the relationship. Everything seems to be frozen. Is there a grounding relationship that I'm missing? Which one is this? Okay, so I'm going to delete both of these. There you go. So now that that comes off, we can constrain it back on so that it'll fit right. My computer also might be a bit slow because it just did a big mirroring equation. So it might take a while for it to get back to like its regular rendering. Okay, so now that moves. So we deleted those constraints that were broken, and I can see that this one moves, and that one moves too. Okay, so us mirroring that fixed it. Okay, and if you remember, I suppressed the constraint that had this going into the point. So what I can do is I can just go back over the constraint, right-click it, unsuppress it, and it'll snap it back as if it never moved. Now, as you can see, when I grab this to try to move it around, it doesn't rotate because it's just moving the whole piece. So if I wanted to test to make sure it rotates, I could just take this part, ground it just for a second, and then take this and see now because it's moving against something that's grounded, we can test it to make sure that these spin. Okay, so they spin. So now let's unground that piece. And let's line it back up. Oops. You're gonna get some weird movements like this when everything is not constrained completely. Okay. So that's moving weird. So let's constrain it to fix it. So basically, when you're building a 4-bar, it's going to be like this, except they'll be flat with each other. So we need to put a bar that goes across the top of here to screw it in, and across the bottom of here to screw it in. So I think that what you should do to just to make sure that something fits is when you go to your robotics CAD, you go to your kit of parts, and then under structure, you can go to the 5-bar and go to open it, and you can just hold it up to see if it would fit right. So this still fit right because you want the motors to be as close as possible so the profile of this is reduced. Another way that this design could be made is actually with the motors on the outside, which could put your center two columns even closer. So if your design requires that, that's actually a good way to do it. So I'm going to place one bar up there and one bar down there, and then press escape. And now let's constrain these. So I'm going to constrain them to the bars that are stationary right now, because as you remember, this is our backbone piece because it's grounded. So let's start by constraining these to it. So you want to screw these in at the very edges, because let me put it in place and then I'll show you. So if this was your actual design and you were building it, you want to have as much reach with these as possible. So basically this can only go as far as either that bar hits the top bar. So like this can only spin as far as until it hits that back bar, right? But we're gonna have to put more support at the top. Like this isn't enough support to make the entire thing not fall apart. But also a problem that you encounter with limited reach, or your possible limits to reach, is this bar sliding all the way up when you're extending. And if you have to, like this back piece right here might interfere with the gears right here. So that's your other limit. Like this can only go back far enough until you don't want it to accidentally hit those gears. So it can only go back about that far. So you have a lot of range, but those are just your two things to keep in mind. That's why we put it on the back. So let's finish constraining that by taking this face and connecting it to this face. And now what we need to do is this bar is screwed in, but this one needs to get screwed in. So if we look at it from a bigger perspective, if we wanted to screw this in right here, we would have to move this over so we can edit that constraint that we made in the last one, this one right here, to test different sizes. So if we wanted to try like maybe reducing the space a bit, see you could maybe fit it in there, but I say that's too close. You want to give yourself a bit more room just to make sure nothing goes wrong. So I would say stick with 3/4 of an inch and just move this bar to be out one more. So that you have 1, 2, 3, 4, 5 holes in between. Because if you have the space in your 18 by 18 by 18 inch limit for building a robot, I would give yourself more space around parts that are spinning and moving, like these gears and this arm, because then it makes it less likely that things will hit each other or mess up. So then let's do the first constraints for our bottom one too. So we're going to make that circle, make sure it's undirected. Okay. And now if you may have noticed before, we don't actually have the circles on this top bar for us to screw it in there. So let's just click the top bar, find it in the browser. You can close all these mates once you finish finding out and diagnosing whatever happened in the mirror. So let's open up this part. Let's put in the orientation as we have it in our model. So it's set up like this in the model because when I come back to this, I can see that we have the 4 holes there. So we know that we have to draw the holes 1, 2, 3, 4, 5 after the edge. So let's go back to the sketch that we created on this face. Click project geometry, and we go 1, 2, 3, 4, 5. This is where we're working. And then change your circle type to a tangent circle, and pick the 3 lines that you just projected. Finish sketch, save the part. And now we have the circles that we need to constrain. So we can just shift it over a bit so we can see them. Okay, so if we shift it over a bit, the screw head, or I would put the heads on the outside coming in, and then put the nut right there. So even though the screw is over here, we can actually use this one to connect it. And make sure to do the second one, just in case if anything comes undone, you still have it connected. Okay, so now this one can't be moved, this one can't be moved, that one can't be moved. And now we constrain this bar to the top, so we really don't need to constrain it down here. That's just a bit excessive. So the next thing that we need to constrain is this other part of the bar. So we want these motors to be close so that we're using as little space as possible, but not so close that it doesn't work. So if I just kind of mess with the part to get it back into place a bit, and look at it from the front, it looks like screwing it in those holes right there would work because we have a bit of space in the motor. If we shift it 1 over, that doesn't work because the motors are intersecting. So it looks like that's where we're going to end up having it. And then since this has to be symmetrical, we have 5 holes in between here. So we need 1, 2, 3, 4. This has to go there at 5. Because we have to make it symmetrical, otherwise that just opens a whole can of worms that you don't want to get into. So we can start by constraining this side. If we drag this part out of it, we can see the circles that we already made and the circles on the bar. And then we want to click this face and this face. Okay, so now that means that this last bar is connected. So the only thing that we're not connecting yet is this center bar. But we don't have holes for it yet, so let's go back to the other part that you should still have open in the browser. Go back to the sketch that we had. And since we know that the last bar is connected here, we know that there's 5 holes in between. So 1, 2, 3, 4, 5. So we know that the geometry we want to project is right here. And then we want to make the circles right there so we can connect it easier. and make sure to save your model. And make sure to save your assembly. Once it saves, you can drag this to the side just so you can see the circles we just made to constrain it easier. And then open up the constraints menu, and I'll just click the top circle and the top circle, and then click one down, get a different view so we can see it, and click the other one that's one down, and click OK. And now nothing moves, or nothing except for these rotating should move. And these rotate. So now, this is the part that will probably take you the longest to build. So now if you had a robot, well actually before we do applications, what you should do is, in reality you would have a bar going across here, because these will, if you don't have something that's going across here bracing these, like one will go up and they'll get all wonky and they won't stay in line and it'll be really weak. So in reality you'd have a bar across here, but while you're still designing, you don't know where the bar will go. So a good thing to do while you don't actually have the bar there yet is you can constrain the top of this face and the top of this face, and now that'll have to be flush, so switch it to flush and then click apply, and the same thing on the bottom, click the top of this face and the top of this face, make sure it's flush, then click OK, and now they'll move together. So your robot would basically have, it would start in this position, something like this. Maybe not as extreme as that. But up here, there would be a bar that comes down and screws into your chassis right there. And your chassis would exist down here in like a square right there. And then basically, since the chassis is here and the bar is there, then when it extends, it'll go like this. It's kind of hard to see it. We'll work on a animation after this to show it better. The robot will go like this, and it'll be all the way up there. Well, then the bar is right there, and the chassis is like all the way down there. So you have chassis, the bar that it's connected to, and then it goes up and then up. So that's basically the main part of the reverse 4-bar finish. I hope that helped.